Assalamualaikum and hi, my name is Aida and I want to explain question number 1G, number 9. Okay, this is RL circuit. Okay, find the current I1 and I2. So KVL for left loop, and we get question number 1, and KVL for right loop, and we get equation number 2. Okay, and equation number 2 substitute into equation number 1. So we get dI1 per dt plus 10 over 7 I1 minus 10. So use formula linear differential equation. So 10 over 7 I1 PT and QT is 10. So formula I equal exponent integrate PT, we get this one. And lastly, we substitute into this in this one formula, and we get I1 for equation 3. So, equation 3 substitute in equation 2. So, we get I2 5 plus 5 over 7 C exponent negative 10 over 70. So, we get I1 and we get 2 I2. Thank you.
Okay, Assalamualaikum. My name is Ainaa. Okay, so here I want to explain for equation 2, exercise 2E. From this script, we can model as this. And first, for IT is equal to I1 minus I2. And then for this loop 1, we can apply KVL. And we can have this equation 2. After that, for loop 2, and we also apply for KVL, and we can have this equation number 3. After that, for equation number 3, we differentiate, and we can have this equation number 4. After that, we substitute equation number 3 and number 4 into equation number 2. So, we substitute and calculate. After that, we have this final equation. From this equation, it is non-homogeneous. After that, we using method undetermined coefficient 2 over 5 m squared plus 3m over equal to 0. After that, from this equation, we have m1 is unequally m2. This is case number 1. So we have I2 in T domain C. A plus B exponent negative 7.5 P. Okay, after that, when we have found IC, and now we have to know what is IP, and then we compare I2P and I2C, which is the same and this is not same. After we have found I2P and I2C is not same, we differentiate from CT to C and then 0. That we substitute this into this equation. We have C equal to 10 over 3, and we have I to P, C T equal to 10 over 3 T, and then we substitute this into this, and we have this equation I2 equal to A plus B exponent negative 7.5t plus 10 over 3t, and then we differentiate I2, and we have equation 5 and 6. We substitute 5 and 6 into equation 3, and we have I1 equal to A plus 2 over 3 minus 1 over 2 B exponent negative 7.5t plus 10/3t. And now we have 2I1 and I2. That's all from me. Thank you.
Hello, I am Aida. I will explain question 3. In this question, we need to prove these two loop system and to get this question. First, we apply KVL for the left loop. We apply and get this answer. And then KVL look for the right loop. We apply and get this answer. After we get this answer, we substitute 1 into 2. We substitute and get this. Then we need to put the answer I1 prime and I2 prime into this equation. -5 and -5/3, 5, 23/15, and 4. And we prove this equation same with this. Thank you.
My name is Almaeldoe and I will explain for the question for the number 2. Okay, this is the circuit, and the value for VRL is V is 24 volt, R is 12 ohm, and L is 4 Henry. Okay, the question needs us to find the current which is in time domain. Okay, this is the equation for the frequency domain, and this is the answer for current in frequency domain. For the partial fraction, first we need to find the value for this equation, which is A and B, and then first we need to find the value for B. We assume S as number -3, and then we get -A. For A, we assume S equal to 0, and then we get 2. Hence, this is the equation. And then we combine the equation together, and then we get this form, which is already in Laplace transform. And then for the word equation, we do the Laplace transform, and then we get the answer in time domain. So the answer is, the current is 2 minus exponent -3t. Thank you.